Right, so I'm just going to continue with these questions on electrostatics. We were doing the Coulomb's law stuff, and now we have a couple of point charges, and we are going to add a third charge in a few of these questions. So in this one, we have one here and one here. Where, in which area or region, could it be to make the force on it zero, to cancel out? Now, if I was to place the other charge, which is a positive one, if I placed it here in between them, he will repel with this one, he will repel, but then he'll also be attracted to this one. So he will feel an overall force to the right. So that will not work. If I place him on the right hand side, okay, so now he is attracted to this, but he is repelled by this. Remembering the formula, F equals K, Q1, Q2 over R squared, the distance is inversely proportional by square. So this is so far away, it's going to be very weak. Not only that, this has a bigger charge. This is closer and bigger. This will never balance out anywhere here. It's just too far away from this small charge. So the only place we can place it is closer to the small charge. So that's a little clue there for you. If you ever want to do balancing or cancelling out, you must place it closer to the smaller charge, because this is smaller charge, but the distance is closer. So if I'm going to do K, Q1, Q2 over R squared, if I am closer to this, and this is going to be like a smaller charge, at least this is a smaller number, and that means my force will be able to eventually somehow balance out, depending on where I need to place it. In this question, you don't need to do any calculations. We will for the next one, but for this one, no need. You just need to get the idea that if you want the force to be zero, you just place it nearer the smaller charge in this case. Okay, so in that case, the answer must be 1. This place here. This will not balance. This is too weak to balance because it's too far and it's too small. This is good because it's closer to the smaller charge, and eventually it can balance. This is further, but a bigger charge. So there will be a 0 at some point. And this one here, 2 charges are fixed on the x-axis here and here, okay? So this is 0 centimeters, and this one is 8 centimeters. So this is 8 centimeters over here. From here to here, this is 0 centimeters, okay. And the idea is, where can I place a third charge to make this total force 0? So, looking at this, this is 6 microcoulombs, and this one is -3 microcoulombs, all right. And I'm going to put a third charge, and what was the trick that I said? It should be closer to the smaller charge. It will be somewhere in this region here. It will be somewhere over here. And we're trying to figure out where. And the way we can do that is we know that the net force should be 0. So if I had a charge here, you should have a force pulling to the left, attraction, or repelling, that one. It could be a plus or a minus. Either way, it will attract with this one and repel with this one. Or it will repel with this one and attract with this one. It doesn't matter about the actual charge. And besides, we use magnitude only. So F1 plus F2 must equal to 0. So what I can just do is just say that F1 will just be equivalent of F2. The same idea. There'll be a negative here, but we can ignore the minus. Okay, so if I know F1 equals F2, I can just write it out. I'm just going to come down a little bit more. I will do K, Q1, Q, so this is Q1, and my new charge will be Q3. Q1, Q3 over R squared equals K, Q2, Q3 over the new R squared. So this is R, and I'm closer by 8. I'm closer by 8. You know what? I'm not going to write the numbers in here. This is going to be R minus 8, so I'll get to that in a second. Before I do that, I need to cancel some. This is going to be R1, this is going to be R2, so they're 2 different radiuses, 2 different distances. But I can cancel the K, they are common. I can cancel the Q3, they are common. So I don't even need to know the magnitude of Q3. All I need is Q1 and R, Q2 and that R. All right. So from this, I can plug in some numbers, and we can use our trusty calculator to get us the answer using shift solve. Let's see. Q1, the value is 6 micro. So I'm going to write 6 times 10 to the minus 6, but I'm just going to write microcoulombs, okay? It's easier to write because I don't have enough space. Divide that by R1, which is just basically going, well, it's just R, isn't it? So what I'm going to write is just R squared, okay? And then what I'm going to do after that, I'm going to look over to the right-hand side. I'm going to put in this one over here is, how much is the charge? Q2 is -3. So I'll just write 3 microcoulombs. And over here, I'm going to write R minus 0.08 or 8 centimeters, cm squared. Okay, I'm solving for R, so this is what I'm looking for. Now, I have the squared here, so I can just take the square root of both sides. If I do the square root of both sides, I can cancel the square. Shift solve does not work with squares very well. So that will just be square root of 6. I can just ignore the minuses and things. I think the final answer will come up like this anyway. Over R, which is what I need, equals square root of 3 over, in a bracket, R minus 8. This is R minus 8. I've removed the square. Now, you can cross multiply, you can rearrange and solve, you can spend all that time doing it, but I'm not here to waste time. I'm just going to directly get over to my calculator and I'm going to shift solve, and I have made a video on how to do shift solve. It's on my channel if you want to check it out. But if you do shift solve looking for R, you will get the final answer, and the R that will be placed should be 27 centimeters away. It should be on the right hand side by 27 centimeters. By doing this, you should get 27. Okay, so I'll just write here, R equals 27 centimeters. 27, very nice. Now, a charge of this Q is on the x-axis at A. Where should the Q2, which is 9Q, be to produce a net electric force of 0 on a charge at the origin? So let me just erase all of that and try that again. Let's draw it out here. Here is my origin. Here is my A. X equals A. This is Q, and this is a random charge. But I need to know where this will be to be 9Q. I need to place a 9Q somewhere on this random charge. There's a charge here, and I do not know what the charge will be. Okay, so I can see that here, this is a plus, and this is possibly a plus. So of course he will maybe repel with him. This is also a plus, which means where can I put him? To the left, in between, or to the right? If I put him in between this 9Q, if I placed it here, he will also repel, so that will not give me 0. If I placed it over here, it will also repel again, because they're both pluses. This will be a plus Q. This is a plus, this is a plus. Both of them will act in the same direction on this charge. Whether this is a plus or a minus, if it was a minus, obviously it would attract to both of them. So this value of the charge, or the sign of the charge, is not important. They will have the same effect. So these two places are not good. The only place I can place it is on the left-hand side somewhere, maybe over here. That way, I have, this is 9Q, I've already got the Q there, and this is just 1Q. Now, this will maybe repel with this, and also that. Or maybe if this was a minus, it'll attract to both of them. Either way, the forces will balance. I hope that makes sense. I cannot be here or here, it must be on the opposite side. Now, you might also remember what I just said to you. It should be closer to the smaller charge. So this idea here. So that means this is a bigger charge. It should be further away to make this 0. This should be closer to this. All right. First of all, I already agreed it should be on the left, so I know C and D are wrong. It has to be A or B. Now, how can I cancel 9Q? Remember, K, Q1, Q2 over R squared, which I've erased. F equals K, Q1, Q2 over R squared. If I make everything 1 times, and I say 9 for the Q, divided by, I have two options. I want to cancel it to balance it out. You can probably guess that I can do 3 squared, because 3 times 3 is 9. That equals 1. That will balance. This will be 2 squared. 2 squared is 4. 9 over 4. It will not balance. I want the force to balance out. So I don't need to do any fancy things. I can just realize that if I was to do 9 for the Q, and to balance the 9 now, I will have to make the distance 3 squared. 3 squared equals 9. 9 divided by 9 is 1. That is balanced. And I already know it's on the left-hand side, somewhere in the negative. This is the origin, this is the negative side, this is the positive side. The answer is A. All right, last question here. Same idea as the previous one. Where could I place a 7 millicoulomb charge so that the net force on it would be 0? So again, I will just draw it out perhaps. I will draw a line. Here is my line. A fixed charge is at the origin. This is the origin, and this is positive 2. This is positive 2 over here. A fixed minus 5 is x equals 1. So this is 1 meter, and this is minus 5. Where can I place the positive 7 charge so that the net force on it is 0? Again, just like before, it should be closer to the smallest charge. If I placed it in between, like right here, again, let's find out what will happen. If I placed a positive charge here, he will repel with this one, and he will attract with this one. Both forces are in the same direction, so that's not good. If I place it on this side over here, same problem will arise as before. I will be attracted to this, and I will be repelled by that, but this is just too far away and too small to balance the force, so that's also wrong. It must be somewhere on this side over here. So the charge will be over here somewhere, closer to the smaller charge, on the side of the smaller charge. You can think of it like that. So, as before, we want the forces to equal to 0. So I'm going to just set F1 plus F2 equals 0, or I'll just go to F1 equals F2, right? This is how to balance them. K, Q, 1Q, 3 over R squared equals K, Q2, sorry for the handwriting, Q3, because I've already done it before, over R squared. Now, I can just cancel the K. This is R1, this is R2. The R values are not the same. I can cancel the Q3. I do have the value for the Q3, but actually I don't need it. I can just ignore the value for this, okay? Because I only need Q2 and Q1 and Q2. That's all I need to figure it out. Now I have Q1 over R squared equals Q2 over R. Now this is not R, this is R minus 1, or I should actually say, well, I can say R minus 1, yeah, because this is 1 meter closer. The difference is 1 meter. So that means, not here, why am I doing that? I'm over here. This distance is 1 meter. So I will write R minus 1, and I will write here squared. Okay, cancelling the squares, taking the square root, put the numbers in. So I already know what Q1 is. Q1 is here, so I will write square root, I'm taking the square now, over R equals square root. Why? Because I'm doing the square root on both sides. Why? Because I can cancel that. Okay, great. Square root of Q2, where is Q2? 5. It's going to be absolute value only, so 5 over, and then I'm going to write R minus 1 in a bracket. This could be your X in your calculator. Shift solve, you will get your answer directly, and it will be, again, we already know it's on the left hand side, and the actual value should give you 1.7. So that would be the answer for this question here, 1.7. There are a couple of questions on this one here. The idea is, this one here, it's really straightforward, just like the other question that we did, which was this one over here. I want to cancel out the 4. If my Q becomes a 4 in this question, what can I do to cancel it? And it's a negative Q, so we need to figure out where the third charge will be to make it 0. You will realize that 2 squared equals 4, so that is going to be the distance. I need to find a 2. So that will not help, that will not help. It's either one of these two. If I was to draw them out in a number line where a charge is on the x-axis at x equals a, so this is my charge of Q1, and then where should Q2 be? Because there will be a third charge at the origin, so this is the origin, this is 0, and this is also Q, it's the same value, so what's Q2? They're both positive, let's say, and then we have a minus. Okay, where am I going to place it to do the cancellation? And where should that charge be placed to make the net force on the third charge become equal? Now, we can try putting it on the left. If you put it on the left, Well, that's not going to help though, is it? Because I am too close to this charge over here, and this is -4, by the way. We're trying to figure out a way to make it balanced. So having it on the left will not be helpful for us because this is minus and this is plus. This will attract, and it will also attract with that one. If I placed it over here, somewhere on the other side, so that's obviously wrong. I can place it anywhere between here and here. If I place it over here, it's another problem. It's -4. It will attract and attract. The idea must be it should be somewhere in between. It should be maybe here, somewhere here, to make this, to balance it. So it'll be between here and here, because if I was to place a minus charge, he will be attracted here and he will be attracted here. So it will be 2. Now, it looks like there is an issue with the question, because if I was to say 2a, it actually means somewhere over here, which would not make sense, because we have a positive charge here and a positive charge at the origin. Where can a negative charge be to make the net force 0? The only way to cancel it out, if this is a minus, it must be in between. The forces must balance out. So by calculation, the answer should be D. But by using your brain, there seems to be a bit of an issue with the question. But either way, all you need to do is take that to cancel out the 4. You will do 2 squared. The distance should become 2 squared. So I'm going to stop there for this video. Thank you.